Hey guys, welcome back to AlgoYogi. We are doing linked list series, and our next problem in the list is design circular queue. All right, so let's go to the problem in LeetCode. It's a design problem, and the description is quite a lot. So I guess I'll read it, but I'm not gonna read it line by line. So design your implementation of circular queue. So we know what queue is. Basically, it follows FIFO, first in first out principle, which is basically the value you're pushing in first, that's the value that gets out first when you're popping it out from our data structure. So, and it's a circular queue, so it doesn't have basically an end. So the back of the queue is connected to the front of the queue, which is also called front and rear. So rear is the end. Well, it's called ring buffer, whatever, it doesn't really matter. Like when it's connecting, it's called ring buffer. One of the benefits of circular queue is that we can make use of the spaces in front of the queue. In a normal queue, makes sense, you're not wasting extra space when you have like some space lying around next to the queue or before when you're popping something from the front. So that space gets utilized when it's connected from the back to the front. Okay, so it's a linked list question, so we're not going to do it using array or anything. Although we can, but we'll do it using linked list. So let's see what all methods we need to implement and how we are actually going to do it. Let me change the view here. So my circular queue is basically the main class. That is what will be used to create the object of this circular queue class. Now this is the constructor which takes the value k, and that is basically the size, initializes the size of the queue, which is k size. So initially you are giving a fixed memory space to be used by that data structure. So initially you're feeding in this value k that will be used to set the space that all the values can be put in. Now front will return basically what's in the front of the queue. If it is not, then basically return -1. Same is with the rear. And then we have enqueue. That is the main method, I would say, which is enqueuing some value from the basically the back of the circular queue. So front is big. This is the thing, it's like first in first out, so you're pushing in the value from the rear of the queue, and then from the front you're popping them out, because whatever you pushed in first is in the front, right? And then it gets out, you pop it out. So and that is dequeuing. Right? So dequeuing and enqueuing, these are the main methods. If you return true if you are able to enqueue or dequeue, and that you can't do every single time, because what if there is nothing in the queue, then you can't dequeue anything, and if there is no space left, then you can't push anything, so you can't enqueue anything. Now these two are basically helper method, usually checking the size if they're empty, not the size, sorry, if they're empty, if the list is empty, or if it is full, not the list queue, although we're going to use the linked list. So how are we going to implement these functions? We're going to use doubly linked list, as I said before. So for doubly linked list, initially we're going to have basically two dummy pointers, and I'm going to call them left and right. So basically left, I could say, is a reference for the front of the queue, and then we will have right, that's basically the rear of the circular queue. However, remember, we are going to make it circular, we're going to connect them, right? So this will basically be pointing its next to, so this is basically next of right, because right was supposed to have a next pointer, and that's pointing to the left, and there will be one pointer, sorry, previous of because it will be going this way, so previous of left would be right. All right, so that's basically connecting them in a circular fashion. All right, now we were gonna enqueue something, so there will be, this will has a size, like when we are creating this my circular queue, we will have a variable called size, and that will have the value k. Now that will be basically to check the edge cases if our has, like, our queue has space to add more values or not. Now let's do this thing. These we can do easily, and this is basically returning front and back. Basically front would be left dot next, that's front, and rear would be right dot previous. All right, so because these are the dummy nodes, we need to return the actual values. Now let's move on to enqueue main function. How we do it? So enqueue would be enqueuing something at the back of the queue, because you are appending something. All right, so that would be basically if you're creating some node which is like cur, you create the node and its next node would go to right, and right dot previous would basically go to cur. But right now we are assuming, there is nothing in between. However, like, there will be some nodes. So let's say there was already a node like over here, and then it was pointing like this, and this initially it was pointing like that. Now what we will be doing is we will be creating this current node. We will be creating this current node, and we will be removing these pointers. So first we are setting its next over here. We will remove this right dot previous is still over here, so right dot previous dot next would become over here. So what's really happening is we are removing this pointer now. All right, and then we can take our current and basically append it, because we still have this access. All right, we still have this access. So I should have, before setting its next, I should have set its previous, cur dot previous to right dot previous, so like that. And then we basically set the next of 2, which was right dot previous. I know it's a lot of next and previous, but that's the way of going. And I think when we write down the code, like, it will become very clear and easy to follow thing. All right, and then right dot previous would now be cur rather than the actual thing. So this is how you enqueue something. And here this is basically is the back of the queue now. And if we were dequeuing something, that will happen from the front. So you were basically setting left dot next, which was 2. Instead of that, left dot next would go to that's next. So left dot next, left will become left dot next will become left dot next dot next, like that. All right, and then for this to go completely, its previous would be set to left. Okay, I think that's it. Yeah, we played around with the pointer. We know how things gonna go. So I guess, like, now we can dive deep into the code and write it down. All right, let me switch the view over here. Okay, let's code up our solution. Now we gonna have a list class. So class for the list node, and we're gonna have not like that, sorry. So we're gonna have basically a doubly linked list. So in our constructor, along with the value and next, we're gonna have previous pointer as well. And I think I am forgetting to provide the self keyword. And now we can simply just say self dot value would be value. Let me give some space here, it doesn't look very nice. And self dot next would be next, and self dot previous would be prev. Okay, that's good enough for creating list node of a doubly linked list. Now let's write the constructor for my circular queue. So k is the size, and let's call it we can call it side, we can call space, whatever. Like let's call it space so that we know it's talking about if there is any more space left. Okay, so in the queue, or if there is space, then we up enqueue. If there is space, then we can also check if it is empty or not, or it's full, sorry, not empty. Now, so self dot space would be, we can call it k. Then we're gonna have these dummy pointers left and right. So self dot left, when I'm creating it, will be a list node, and we can give it any value. I'll give it 0, -1. If you want to give -1, you can give -1. Then it's gonna have its next as none, because we're creating this node out of blue. Like, it has no reference. It's just it's the first node of our circular queue that you're creating, and it has to be basically given these none references in the beginning. Very sad, right? But when you're creating right, then that previous can easily be self dot left, right? So my right's previous, instead of none, can be set to, to create it circular basically. So its previous can be set to self dot. So self dot right's previous is self dot left. Okay, so, and then self dot left's next could be now easily self dot right. Easy peasy. Okay, that's the constructor for our circular queue. Now let's write if our queue is empty. That means what? If something is empty, that means my left's next is right, and yeah, my left's next is right, so that they don't have these dummy nodes, don't have any nodes in between. So return if self dot left is equals to basically self dot right. Okay, then it's empty. And in order to check if it is full, then we can check return if self dot space is equals to 0. Then it means we have consumed all the available spot that were given to us by the number k. Okay, now how about the front? How do you return the front of the queue? That's gonna be, first we gotta check if it is empty. If self dot is empty, we can check that. If self dot is empty, then that means we do not have a front. If this is the case, then we can just basically return false or -1. I think that was you return true or false, I think. So we can return false here. Otherwise, wait a second. I'm just trying to check the description. So it's a boolean. It's the return value is boolean for the is empty, and I completely got confused here. So if this is the case, then we are basically returning -1. Otherwise, you return the self dot, because it's the front, then our left dummy node is in the front. So left dot next dot value, because left is a dummy node, you want to return what's next to it. And if it was empty, then we don't have to basically return, we don't have any nodes, so we're going to return -1. Same thing we're going to do for the rear, but we're gonna check it like this. So this part will be same if it is empty, then we basically return -1. Otherwise, return self.write.previous.value, because it's the back of the queue. So these functions are done. Now our most important functions. Let's do enqueue first, because that's actually the main function, like enqueuing some value. So how do we do it? Enqueuing is happening at the back of the queue, right? So first first we need to check if we have a space left. Okay, so if self.space is basically if self.space is 0, initially it's k, so if self.space is 0, that means we can't append anything. That's why we will return I would say false. I think that's what it said. If we are enqueuing something, and the return true if the operation is successful, otherwise false. It has a boolean return value. So otherwise we can enqueue something. So if we are enqueuing, we said when we were trying to understand this algorithm of enqueuing, is like we're creating a current pointer which will get appended or inserted between the write and write dot previous. All right, so I'm gonna say list node. So list node value would be value that's given to us, and what's gonna happen is, how about its next node would be self.write. Remember, we are inserting it right before the write dummy node, and its previous would be self.write.previous. Self is still holds that previous, so now current is basically somewhere, we are keeping it over there, but now those next pointer of the previous pointer of the cur is at write.prev, and cur.next is at self.write. But we're going to change now. How about that previous is next? So this is what I mean, self.write.previous. What about its next? That its next was basically write earlier, but now it could be current. So this next would be at cur. All right. And what about the previous pointer of self.write? So self.write.prev would be now at also cur. Okay, and cur's next and previous we have already set to write and write.prev. So I think that looks pretty good. And also we're gonna, since we are enqueuing, so we're gonna decrement the space, right? So by 1, we are consuming available spaces. So, and then we can just finally return true. Okay, because that's what it wants. How about dequeuing? Dequeuing is happening at the front of the queue. All right, now we have a dummy node, self.left. Self.next is the place, is the node that we gotta take out of our circular queue. So in order to do that, first we gotta check if we have if it is not empty. So how do we do it? And I'm just thinking if we should have checked using these functions over here, but it doesn't really matter. We're doing an okay thing. So in order to dequeue, if this is empty, then we're gonna return false. So if this is empty, because we can't remove anything from an empty list, then you return false. Otherwise we're gonna do self dot left dot next, skip that next pointer, so we're gonna remove this thing. So self dot left, it's just so much pointering, man. I'm just so tired of like next, next, next. God, okay, self dot left dot next dot next, okay, because we are getting rid of this one. So this node, this is a reference, but that next pointer is going to the next But what about now self dot next is the skipped node, the node that the one that was removed, its next node, but it's previous now. Self dot next dot previous would be self dot left, okay, and we're gonna self dot space and by incrementing one, because we removed something, so we have one more space where one more value can go, and then we return true. And now I'm just thinking, if I should checking it by myself, I could just use my empty, or I think that could have been if it is full. I think that's what they wanted us to use, not the empty. So self dot full, if it is full, then we can't enqueue anything. I think that's it. I think I was already zoomed out, so let's run it. It doesn't have any attribute called next, so self dot left dot next. I think that is it. Awesome, dude. Okay, let's submit it. Honestly, passing, and I did a small mistake here. So self dot left is not what we are checking. Self dot left dot next, because they're definitely different nodes, right? So that's not what we were checking. We were basically checking for empty is like self dot left dot next, not left and right. They're separate nodes. They can't be equal anyway. Okay, this is done. Talking about time complexity, I would say enqueuing is basically, I think they're all happening in big of 1, right? But yeah, that's the beauty of this. They're all happening in big of 1 time complexity. I think you guys can write it down yourself. All right, then we can go back to AlgoYogi, mark this solved, and see you guys in the next problem.